Hi guys, today we're going to look at lesson 6.1. And I know I said that in the last lesson when I introduced this unit, but that video went on for too long. So this one we're actually going to look at 6.1. So we're looking at average speed as an introduction to what rate of change is. And you'll see that rate of change is continued on in the next lesson and is actually incorporated to all the lessons thereafter. So at the end of this lesson, read over the notes a bit more, and then you should be trying to work through some of these homework questions. Number 4 is already answered for you at the end of the lesson note. And I'd like you to take a picture of 5 and 6 and send it to me to check over. Okay, so let's get started with 6.1. Okay, so rate of change is a way of looking at how one measurement, in this case distance traveled, compares to over an amount of time. And we call this speed. In Canada, we measure speed with kilometers per hour. Okay, so the equal signs here mean that these all are referring to the exact same thing, different ways of saying the same thing. Okay, so let's look at a graph here. Okay. Here we have a car that is traveling a certain distance over a certain amount of time. You'll notice that along the x-axis on the bottom, that the time is increasing in set intervals, right? The 1 is equally spaced from the 2, equally spaced to the 3 and the 4. X always goes along the bottom. Oh, that looks kind of like a Y. There we go. X and Y always goes up the side here. Okay, we'll talk about that in a lot of lessons. So to figure out the average speed that this car is traveling, we have to pick any 2 points. And you can see that there are points here, there's a point here, here, here. There's points all along here too, but you can see that they're not nicely on the grid lines. They would be really hard to determine exactly what those values are. But at this spot here, we can see that after 1 hour, okay, the car had traveled 75 kilometers. So that's a nice, easy one to read. And for this point, after 3 hours, whoop, that was a little wiggly. Let's try that again. After 3 hours, there we go. Okay, the car had traveled 225 kilometers. Okay, so that's what those points are referring to, and they're nice and easy to read, so we will use them. There we go. Okay, so we are going to learn about the difference in, from this point to this point, what is the difference in the distance between these 2 spots? Okay, and because we're going up, that's called the rise. And the rise is measuring the difference in the distance. So we're going to take the latter distance and subtract the first distance. So if we do the second distance minus the first distance, we get 225 kilometers minus 75 kilometers, means that in between those 2 points, 150 kilometers was traveled. For the run, we are going to run sideways, and you'll notice, well, you won't notice, but my arms are mimicking a run. So from this point to this point over here, we're just going horizontally. The run is the difference between 3 hours and 1 hour, which is 2 hours. Okay, so then if we want to find out the rate or the speed, we have to take our difference in distance and divide it by our difference in time. And we determine that the speed or the rate of change is 75 kilometers per hour. We get a positive answer, and our graph is positive going up to the right. Okay, now I've broken this down into a lot of little mini steps, right? Over here we have a kind of a chunk, over here we have a chunk, and then down here we put the chunks together. This was just to help you understand it for the first time. After today, you need to combine all of these steps into one nice, neat equation. Remember, that's our goal in high school, is to have everything for a whole question in one equation right from the beginning. Okay, so we're going to start to see that on the next page. But first, we're going to review what we just learned, okay? So speed is distance divided by time. Our distance was calculated by the up and down change, the rise, and our time was calculated by the horizontal change, the run. And I'll go over those again up here. Right, our rise is the difference between this point and this point, but just the vertical difference, and the run is the horizontal difference. Okay, so that can be represented by these symbols here. Okay, where we have a triangle, which means change or difference. So the difference in our y values divided by the difference in our x values. And we're going to elaborate on that even more in a moment. Okay, let's look at another example of the same idea. So now we have Natalie skating. So we know that somebody skating is going to be slower than somebody driving. But let's take a look at this graph here. Okay, so here's a graph of Natalie's journey. And again, we can pick any 2 points. I picked these ones. So after 5 minutes, okay, Natalie had traveled 1 kilometer. And after 25 minutes, Natalie had traveled 4 kilometers. Okay, but again, you could pick any point. If I look here, after 15 minutes, Natalie had traveled 3 kilometers. So you could pick that point if you wanted. You can pick any points because the average speed should be constant through the whole thing. Okay, so from this point to this point, let's figure out our rise. How much are we going up by? Okay, so we're going to take 4 kilometers and subtract 1 kilometer. So it's a difference of 3 kilometers. We're going to do our time, 20 minutes, subtract 5 minutes to be a difference of 15 minutes. Okay, and then to get our speed, we take our kilometers divided by our minutes, and we get that Natalie is going 0.2 kilometers per minute. So take a moment and think of how far a kilometer is. Okay, that would be like from North Park School to maybe the McDonald's, something like that. So you're not going to get very far in a minute, right? We know that there are 60 minutes in an hour. So if we multiply that by 60, we could get a speed per hour if we wanted to do that. Okay, so I want you to take a moment, reread over this page. It's attached in a PDF file on the newsfeed and in the content. And when you feel like it makes sense, we're going to look at the next page where we take these 3 separate steps and combine them into one equation, one step. Okay, so we're going back to a car and we're measuring kilometers per hour. Okay, so here you can see a lot of craziness. I'll kind of, whoops, sorry, didn't mean to do that there. Okay, so you can see there's all these points on the line and you can pick any of them. So to prove a point, we are going to first do this line segment A, which is the difference from this point, the very beginning, 0 times 0 kilometers, to this point, 1 hour, 80 kilometers. Then we're going to do the difference from this point, 2 hours and 160 kilometers, all the way up here to 5 hours and 400 kilometers. Okay, and then we're going to do this point here from 3 hours and 240 kilometers to 4 hours and 320 kilometers. And we're going to take the difference in distance and the difference in time, and we're going to combine it all into one step. So our rate or speed is equal to the rise divided by the run. Rise is our change in our y values. Okay, run is our change in our x values. And so our change is calculated by taking the second value and subtracting the first value. Okay, so let's take that equation and apply it to the different line segments. Okay, so first we're going to apply it to line segment A. Okay, I'll scroll up here a bit so we can see that. Okay, so here from this point here to this point here is line segment A. So we can see that 80 kilometers subtract 0 kilometers is our distance change, and 1 hour subtract 0 hours is our time change. So that works out to be 80 kilometers divided by 1 hour, which is 80 kilometers per hour. So the average speed during this part of the journey would be 80 kilometers per hour. Okay, let's try that with line segment B. So that's represented by this green line here. Oh, where are we? Okay, this green line here, and these kind of pinky purple lines that I just drew on. Okay, so we're going to go from 400 kilometers, the rise, down to 160 kilometers. So we take that second value, subtract the first one, and that means that the difference is 240 kilometers. From here to here is 240. Then we're going to do the run, so that's the difference in our time. From here to here, 5 minus 2 is 3 hours, and when you divide those, you get 80 kilometers an hour. And our third one, oh, it looks like my screen is frozen. Maybe? Yeah. Okay, so the third one, we would pick these two blue points, okay? So find the difference in the distance divided by the difference in the time, but setting it up all in one equation, okay? Just like this. y2 minus y1 divided by x2 minus x1. Okay, what do you think the answer would be? Notice that we have a nice straight line here. Okay, so take a guess at what the answer would be. And once you've thought about it, check out this lesson note in my PDF file and see if your thoughts were correct. Yeah. Okay, since this program is no longer responding to me, there's one more example of somebody on a bike cycling. Same idea, just different numbers. So have a look at that in your PDF. Email me with any questions. And then I'd like you to, also in the PDF are the answers to the first textbook question. So try it out without looking at the answers, and then take a peek back in that PDF file for the answers, see how yours looks compared to mine, and then try out the other two questions and send me a picture to check it over for you. Okay, guys, again, your work, you're trying to make your work look like this one here, not the stuff on the front, okay? You want to get it more condensed like this. So good luck, and I look forward to seeing your efforts. Take care, guys. Bye.